Alright, so today we'll be starting with the topic determinants. We did matrices in the previous lecture, and today we are going to cover determinants. And it's another important topic which is being asked at every level. So a question each year has been asked of the determinants, and it is a bit different from what you people seek at boards. Okay, so boards generally, okay, if I talk about the board, this first of all, let's see what all we are going to cover in today's topic, that is properties of determinant, use of factor theorem, multiplication, summation, differentiation, integration of the determinant, and system of linear equations. So board basically fixes you on the first and the last topic, whereas properties of determinant are not the main topic which is being asked at the JEE Mains or the entrance examination. So all the remaining topics are much more important if you ask me on the entrance front, and that is the target of this particular lecture. So I will not be devoting too much of my time on questions which are involved using properties of determinant. I believe that is specifically for the board. You can do it on your own. So I'll be focusing on the topics which are not in the boards. Okay, so let's start the topic. Okay, let's just quickly wash away with the properties that we should actually understand. The value of the determinant remains unchanged if the rows and the columns are interchanged. So that is nothing but if you take the transpose, then the determinant does not change. You can see that A1, A2 here, A1, A2, A3 were the column 1. Here they become row 1. So if you take the transpose, then you can say A transpose determinant is nothing but equal to determinant A. This is what is meant by this property. If any two rows of a determinant can be interchanged, the value of the determinant change sign. Okay, so this is something important which you need to keep in mind. So if I say this is my, let's say, row 1, here this row 1 becomes row 2 and row 2 becomes row 1. So that means you have done swapping of row 1 and row 2. So if you say I have done swapping of two rows like this, or let's say any column 1 is swapped with column 2, so then D new will be nothing but minus times D old, right? A minus sign will come in front of determinant. Okay, so this is a very important property. And if you change the interchange the rows twice, obviously the new determinant will again be same as the old one. If a determinant has all elements 0 in a single row or a column, then the value is 0. So for example, the elements in all the first row here are 0, so the value of the determinant comes out to be 0. So it could be in a column also. If any determinant has two rows identical, then also the value is 0. So you can see here the row 1 elements A1, B1, C1 and row 2 elements, that is A1, B1, C1, exactly similar. That is why the answer is 0. Okay. The other property says if all the elements of a row are multiplied by the same number, then the determinant is also multiplied by the same number. So for example, here row 1 is being multiplied by k times a, so it is multiplied by k. You can say the elements then become k times a1, k times b1, k times c1. The value of the determinant will also be the k times the previous value. Now this is something different from, so you can say this is different from what you did in matrices, right? Different from matrices. Right, in matrices what you did was that every element will be multiplied by k. Here what you can understand, if you multiply a determinant, the other way of seeing this is if you say k times d, this means any row or column is multiplied by k, right? This is what is meant by this. Whereas if this has been k times determinant a, that means all elements are multiplied by k. So this is a very important distinction between matrices and determinant. All right, so you need to keep mind of this. Okay. Next is if each element of a row can be expressed as sum of two terms, then the determinant can be expressed as sum of two determinants. So that means I've taken already an example. So it is a1 plus x, b1 plus y and c1 plus z. So you can write a1, b1, c1 determinant at a time, and then you can split them using a plus sign where x, y, z will be the rows of the row 1 of the other determinant. So this is how you can split. Okay, but you have to split one at a time. So if there are, let's say, for example, if it had been a plus x1 here, right? Let's say b plus x2, c plus x3, and then there would have been some other elements here as well. So for example, you could have said a plus y1, b plus y2 and c plus y3, and here it is a constant, let's say a1, a2, a3, whatever you want to. So you can split them now also, but you will split one row at a time. Okay, so the first element that you want to write would be something like this then. Okay, so you have splitted the row 1, but you will not be able to split row 2. You have to split one at a time, right? This is what I meant by splitting one at a time. Though you can now even split this also. You can further go on and split this, but not at this point of time. And this will be x1, x2, x3. And this row will come again here, and this row will again come here. This is how the splitting has to be done. Now you can split this determinant again using the same property. Okay. The other property that we have to do is the value of the determinant is not altered by adding two elements of any row, a constant multiple of the corresponding elements of any other. So this is nothing but row transformation. So the value of determinant does not change if you do something called row transformation. Remember this, right? So row transformation does not changes the value of the original determinant. So whatever row transformation you use, determinant does not change. Very important property. Okay. Okay, now let's take a sample problem to understand how do we apply properties in basic questions, right? We want to simplify this particular determinant. So now understand, even at board level, so at board specifically, if I talk about board, so what is the target? That target is using row transformations, row or column transformation, whatever you want to use, row or column, right? By either row transformations or by column transformations, your target is to make two zeros in a single column or a row, in a single row or a column. This is the target, right? If you do not do this, you will not fetch marks at board level. So irrespective of this, you will fetch marks at the entrance level. But yes, this will definitely ease out the process. Why we said? Because it eases, this will ease out the calculation component. So least calculation will be done if you have two zeros. Why? Because we expand determinant. So why we are saying this? Because we expand the determinant by a row, right? Expand the determinant by a row, and I'm believing that you people know how to expand a determinant, and then the determinant can be expanded by any row or by any particular column. That is not a problem. So let's say I'll take this as determinant D. Now this is given as A, B, C. So in these type of questions, you have to look out for symmetry, right? You have to find out what is symmetry there. You can see the cyclic order A, B, C, then B, C, A, and then C, A, B. There is cyclic order. But this cyclic order is very helpful for us, because if you do this transformation, that is row 1 goes to sum of all the, right? I hope you can easily see this, right? So this becomes A plus B plus C. So the row 1 elements actually become all same. That is B plus C, C, A, and C, A, B, right? And then you can take A plus B plus C common. Remember that this common can be taken because it is common in the whole row, right? Whereas we cannot take this common if this would have been a matrix. So matrix, for a matrix, every element has to have this particular component, then only we can take this common. Okay, now what you will do, you want the target is to have two zeros, right? So how we can have two zeros here? Okay, no, not a problem. Then I will use, let's say column 1 goes to column 1 minus column 2. Again, not a problem. Then what will be the value of D? You have already got A plus B plus C outside. Now what you will get? 0, B minus C, C minus A. And at the same time, what you can say, the next transformation that I am going to apply is C2 goes to C2 minus C3. So this makes this also 0, and this becomes C minus A minus B, and this is 1, and this is A, and this is B. Now your job is over actually. Your target was to make two zeros in a single row or a column that is there. So this is 1 0, this is 1 0. Now just expand by row 1. You could have expanded by any row, but I have two zeros in the first row, so expand by first row. This is what I will do in this particular problem. So this implies D is nothing but now what? A plus B plus C. And if you expand this, you can see that you have least calculation in that particular way. Why? Because you will get B minus C into A minus B, right? This will be minus C minus A square, right? Okay, so do not leave the answer at this particular stage. You need to further resolve this to get to the simplified form. This is A plus B plus C. If you solve this, this will be what? BA minus CA. This will be what? Minus B square, and this will be what? Minus plus BC, right? And from here what you will get, minus C square minus A square plus 2AC. This is what you will fetch. And if you combine all of these, let's see what you are going to fetch. So A plus B plus C, this will be minus A square minus B square minus C square plus this AC will become, yes, plus AC, right? So this will be plus AB plus BC plus CA. This is what you are going to get after this. Okay, now this is where the algebra comes into the play, and that is why this topic comes in club with your basic formulas of algebra. Can you remember what formula is this? So if you have not remembered, this is the time to remember that formula, and that is the reason that I have also taken this particular case. There is nothing but a cube plus b cube plus c cube minus 3abc is nothing but a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. So this is the final answer that you people need to match, right? This is how you much simplify a determinant. Also, it will be better if you can remember this. Okay, my advice to you is that remember this determinant. This is something very important. If you can remember this determinant, why I am saying that you can remember this determinant, because it is a cyclic determinant. Why? It is a cyclic determinant. That is the reason I am trying that you should remember this. Okay. Okay, now let's understand the concept of factor theorem to quickly resolve the determinant. So this is something which is given to you: a, b, c, a square, b square, c square, b, c, c, a, and a, b. Again, understand this is cyclic in nature. Can you see the cyclic property? Because if I say this, this and this, you can find the third. This and this, you can find the third. If I give you this and this term, you can find the third element of the row. So this is basically cyclic in nature again. And how we are going to use factor theorem now? Let's see. This is something very important if you people have not being acknowledged of this, right? Let's see. So if this is the determinant D, so D I can say is basically a equation in terms of A, B, and C, right? So I can say D is nothing but a function of A, B, and C. That is what I can say, right? Clear? Okay. Now if you can tell me how we use factor theorem. So what is factor theorem? Let's first of all understand this. So if I say by putting, if there is, let's say fx is an equation, right? And if you say if a is equal to 0, what do you mean? That x equal to a is root, right? Is a root. Or what you can say, or x minus a is a factor of fx. This is what you say. This is what is factor theorem. Okay, now let's see how we are going to apply this in this particular case. Okay, now let me show you what I am going to do. So let's say I take a is equal to b. I put a is equal to b here. So what will happen to the determinant? If you put a equal to b, this will be what? B square, and this will be what? BC. So this becomes 0. Why? Because you can say column 1 will be equal to column 2. So if this is happening, this implies that a minus b is a factor of d. This is the use of factor theorem, is a factor of d. Now similarly, if you do the other step, that is b is equal to c, I can say b minus c is a factor of d. Similarly, if c is equal to a, then I can say c minus a is a factor of d. So this is what is the use of factor theorem, which is even applicable in determinants. Okay. So now what you want is that up till now you have decided that d can be written as something as a minus b, b minus c, c minus a, and something else have to be multiplied that I don't know. Now the target is to figure out what is this particular step over here, and for that, first of all, we also need to understand one more thing. Let's go to the diagonal elements. So these are the diagonal elements, these three. So if you multiply them, so if let's say if you multiply these diagonal elements which I have taken, that is a, b square and ab, and if I consider them all as a equal let's say parameter or variable, so what is the net power? Can you tell me what is the net power here? This is 1, 2 added 3, 4 and 5. So net power is 5. So you should actually get a power 5 polynomial in terms of a, b and c. This is what is the required statement here. So up till now you have got this power 1 in each term and power 1 each term. So if you take this total becomes power 3. You require something here which has net power of the variable as 2. This is the target. And how we can take, since again it is cyclic, so in terms of cyclic, how this particular number can be taken is that either it will be, let's say, a square plus b square plus c square. Why I'm saying cyclic? Why can't you think of that only, sir, it could be a square? It is not possible that it will only be a square. It will be a square also, b square also, c square, because of the cyclic property. Because if a is coming, then b square will also come, then c square will also come. So you can see that each term has, yes, power 2. Or you can say, sir, or you can have mu times, I'm figuring out what will be the value of lambda and mu. This could also have something like AB plus BC plus CA. Can you see this? Now also each term has power 2 and this is completely cyclic. So these two terms are completely cyclic and has power which is nothing but 2, which is the requirement. So now your target is simply to find the values of lambda and mu. So just let me rub the screen so that I can tell you that how you are going to solve this further. So this is how I can write that this determinant is nothing but equal to this. Now you need to find the values of lambda and mu, and how we are going to find the values of lambda and mu is by hit and trial, right? We will use hit and trial by putting different values of a, b and c. Why? Because this is now becoming an identity in terms of, so now this is identity in a, b and c. That means whatever value of a, b and c you put, LHS should always be equal to RHS. So case 1, if I want to take and simplify this, so let's take the easiest case. How we are going to the easiest cases? Let's take an example. So put a equal to 0, put b is equal to 1 and put c equal to -1. Why I have done this and why I have not taken all of them 0? Because if you take all of them 0, this quantity will become 0. You don't want to take this as 0, because otherwise you will not be able to find an equation in terms of lambda and mu. So now if you take this, what will be the value of RHS? So let's take the LHS first. So this will be 0, this will be 1, this will be -1, this will be what? Again 0, this will be 1, this will be also be 1, and this will be what? BC is -1, this will be 0 and this will be 0. Can you see that how easy calculation has become for this particular question? So you need not even go ahead and solve the complete determinant. It has completely reduced to, already there are 2 zeros. So that's why I was taking one of the elements as 0, because it will drastically reduce your calculation of determinant also. And let's take what will be the RHS then. Okay, so the RHS would be a minus b. So a minus b will be -1, b minus c will be 2, c minus a will be nothing but again -1. Can you see that? All non-zero. Because if this is non-zero, then only you will get the finite value in terms of lambda and mu. And what this will be? Lambda, a square is 0, b square 1, c square. So this is 2 plus this will be what? AB, all the terms containing a will be 0 and you will only get BC, which is nothing but minus mu. And if you calculate this completely, this is what you are going to get, or we can say that 2 lambda minus mu is equal to -1. This is the first equation in terms of lambda and mu. We need to find another such value. So for case 2, let's pick another value of a, b and c, and the other value that you can pick now is that let's take a equal to 1, b equal to 2, and now take c equal to 0. Again, the target is to take such that the RHS is again non-zero. And now if you see what all values this will take, 1, 2 and 0, right? This will be what? 1, 4 and 0, right? And this will be what? Wherever you will find c, make that element 0, right? And this will be what here? Yes, only AB term will remain. AB is nothing but 2. So again you can see you can expand it by column 3, and this will be what? A minus b is -1, b minus c will be 2, c minus a will be -1. So again non-zero, right? And what is the value of lambda times this? This will be b square, so 5 lambda, and this will be what? Only the term of AB will be counted, that is plus 2 mu. So again you have got a linear equation in terms of lambda and mu again. And if you solve this determinant fully, so this is the equation that you people will get eventually. And if you can see, this is now nothing but linear equation in 2 variables in terms of lambda and mu. You can just calculate them to find the value. Okay. and if you solve them you will get nothing but lambda as 0 and you will get the value of mu as 1. This is the answer that you people will fetch. So if you just want to find the answer, then what will be the answer? Just put the values of lambda and mu here. So the answer is nothing but a minus b, b minus c, c minus a, and then lambda is 0. So this term will not be there. You will only have this term which will be multiplied by ab plus bc plus ca. So this is how you are going to solve this particular equation using factor theorem. Okay, I hope the application of factor theorem is clear in this particular case. Okay, now let's take the next concept, that is multiplication of two determinants. So if two determinants are there, how you are going to multiply them? So let's take this as the first determinant and this as the second determinant. So now we know that we can multiply using the matrices formula as well. So what you used to do in matrices, that is product of two matrices, similar stuff is there. You just have to replace the sign of determinant. As you can simply see, a1 l1 plus b1 l2 plus c1 l3, this is the first term. Then a1 m1, b1 m2, c1 m3 is the second, and so on you can find. This is something which I have taken, you can say, row into column approach, right? This is what you have done standard, whereas I can also write row into, so what I can do is I can multiply row into row also. That is not a problem in cases of determinants only. Remember, you should not apply this in case of matrix. So what I will now write, a1 l1, right, plus now I'll multiply row 1 and row 1 only. So this will be b1 m1 plus c1 n1. Okay, so similarly if you want to find the other element, then other element will be row 1 and row 2. So this will be row 1 is a1 and elements of row 2 a1 l2 plus this will be what, b1 m2 plus c1 n2, right? So this should be n2, sorry, my bad. Now I think, but I may have made my point clear that how it has to be interpreted over here. Then the third one would be what, a1 l3 plus b1 what, m3 plus c1 n3, and so on. This is how you can also find the product of two determinants. Okay, so if I want to start the next one, yes, now you have got the point. This is how you are going to write the next element. Okay, so this is how you can fill row into column and row into row. Both of the cases are valid in this particular case. So now let's see its application in question straight away. Now this property is effectively used in entrance examination because it reduces the calculation of the question, and 99% of the cases the answer comes out to be 0, right? So for example, I have taken this particular question where you want to prove that the value of this determinant will be equal to 0. देखें कैसे करेंगे? So let's see. So you have everywhere cos a minus p, right? Cos a minus q and so on. What is the formula of cos a minus cos a minus b? So this will be what? Cos a cos p plus sin a sin p. This is what is the requirement, right? So if I just start putting the values here, so the first term is something like cos a cos p, right? This looks like product of two terms. Then you are adding something. So now you have to understand, whenever you get something of this sort, so there are two terms which are getting added, there has to be a third term also. Now going just back here, you can see this is something a1 l1 b1 m1 plus this particular term which is missing here, right? So do not worry, we'll see to it what is going to happen with that. Then the next code, again the term that you can see is cos a, then cos q, again the multiplication of two terms, very good. But next term is again sin a sin q, and still you are missing the third term. And similarly the next particular element of the determinant is cos a cos r plus sin a sin r. We were expecting another particular term. Why? Because if you notice in multiplication, what we do is generally a1 l1 plus b1 m1 plus c1 n1. This could have been what? a1 l2 plus b1 m2 plus c1 n2, and so on, right? So do not worry, this particular term is missing. So I can say this is nothing but, if it is not there, then it is 0. If it is not here, it is 0. If it is not there, I can say it is 0, right? This is what I can say. Now if I want to split them, now let's see how I am going to split. Let's take cos a here, right? Now you want to multiply this cos A with cos P, so I have written cos P here. Okay, now you want to add this with sine, so here let's say I write sine. Okay, so this is sine A. Now you want to multiply this with sine P that I have written here, right? So if you start multiplying row 1 with the elements of row 1, you will get cos A cos P plus sine A sine P, which is completely valid up till this point. But you do not want any term here, so I can say this is 0, right? And I do not know whether this will be any term here or not, but I just put lambda, right? Because whether you put any value here, this will come out to be 0. Now you want this particular element, next element. This will be what? Cos A cos Q. So you want to multiply this with cos Q, so cos Q here. Then you want to sin A multiply with sin Q, same pattern, sin Q. And this doesn't matter whatever it is, so lambda 1 or let's say lambda 2, I don't matter. Then you will have cos R sin R and lambda 3, which doesn't matter. Similarly, if you can notice, the next row of this particular term is going to start with cos B and something here with sin B, and the third one will be going to start with cos C sin C. So the same pattern has to be repeated here. This will be cos B sin B, and this element will be 0. This will be cos C sin C, and this element 0. Now can you notice that all the elements of this column are 0, so the value of determinant will be 0, and I do not know what this D2 will be, but answer would be 0. So the answer of this determinant is nothing but 0, and this is how we actually use multiplication of determinants in formula or basically in questions. Okay. Now let's take the next question to understand the concept of multiplication of determinants. So here you can see the first element is a1 minus b1 square, right? And this is, if you want to simplify, this becomes a1 square b1 square minus 2a1 b1. So it has actually 3 terms, right? It has 3 terms. So I can now again immediately think of this is basically, I can fetch this from product of 2 determinants, right? And now I have to just think of how it can be converted into product of 2 determinant, that is the target. Okay, so now let's see how we are going to do this. So first element you want is a1 square, so I just straight away put a1 square here, right? Next you could actually take, okay, so a1 here, so in the next determinant that you are going to multiply, I need this 1 here. Okay, now you want next term to be b square, so let's take b1 square. Now I am basically giving you an example of column multiplication also. So this will be 1, so this is a1 square, this is b1 square. Now I am taking, you understand that I will be doing row into column multiplication, as different from the earlier example that I have taken, where I have gave you the example of row into row multiplication. Now you want again minus 2a, let's take minus 2a1 here, so this will automatically become b1. Got it? So this is how you will get the first term. Now the second term here has to be a1 minus b2 whole square, right? So what this is, nothing but a1 square plus this is b2 square minus 2a1 b2. This is what you will get. So a1 square, this should be, that means 1, because this is already a1 square. Now you want to get b2 square, so yes, I'll take b2 square over here. Let me just remove this so that you can easily understand what I have done. Okay, now you got it. So this is b2, and now you want minus 2a1 b2. So minus 2a1 is already there, this should be b2. Okay, the third element you wanted was a1 minus b3 square, so this will be a1 square plus b3 square minus 2a1 b3. Similarly, this will be 1, this will be b3 square, and this will be what? Only b3. Can you get the point now? And by symmetry, then easily you can just quickly fill the remaining elements, which will be on the similar pattern. Okay, minus 2a3. Okay, so these are the 2 determinants that you people will be taking in this question. I can take minus 2 common from here. So now let's see what this determinant will actually become. This is 1, 1, 1, and this is a1, this is a2, this is a3. Okay, and this I'll take minus 1 common. Why? Because I'm going to swap the row 2 and row 3 just to make that pattern symmetrical, much more symmetrical. Okay, this is what you people will get now. So now if you want to solve this particular case, now you can solve this using factor theorem. This is where factor theorem comes in handy. So now you can use factor theorem to solve this. Right? How factor theorem is getting used here? So if you place b2 equal to b1, let's say, or let's say b1 is equal to b2 by the same pattern that we used to do earlier. So determinant value will become 0 in this, only in this case. So let's say b2 is equal to b1 is equal to b2, right? So that implies b1 minus b2 is a factor, right? Similarly, if you put b2 equal to b3, again this will occur, and I can now say b2 minus b3 is a factor. And since I can say b3 is equal to b1, again it is 0. So b3 minus b1 will be the factor again, right? So that means the value of determinant might be b1 minus b2. So minus b2 minus b3 into b3 minus b1. So this, all these three terms must be there for sure. We just need to check what will be the remaining terms, as we did in the case of factor theorem. Now let's see the elements which are on the diagonal. One element, second element, and the third element. So the diagonal elements are 1, b2 and b3 square. So what are the three terms? They are giving you the net power of the variable as 3. Here it is linear, linear, linear. So again the power is 3. That means this is the only answer. You will not need to take any other factor in this question. So this is the only answer in this particular case. Now if we talk about the other one here, it is actually, you can say, completely similar to what we have here. How? Just transform it. So if in this I say, first of all, what I'll do, I'll change these two. So let's change column 2 is being swapped with column 3, right? And then I'll also swap the new column 3 with new column 1. So what this determinant will look like, it will become something like this: a1, a2, a3, and this will be a1 square, a2 square, a3 square, right? And since I have taken or swapped the columns twice, that means it will not change the sign. Minus 2 will remain outside. And now even if I take the transpose of this, right? So the transpose does not change the value of the, exactly. So it will not change the value of the determinant. So you can write it as this also. And you can see this is completely similar to this. Only the difference is that here it was b1, b2, b3. Here it is a1, a2, a3. So the answer to this particular determinant will be nothing but minus 2 times a1 minus a2, a2 minus a3, and a3 minus a1. Now you just need to multiply this and this to get your answer, which you can easily see because there is already a minus 1 here. So let's take this here also. So minus 1 into minus 2, 2, and the rest is the answer which is already written on this particular proving part. Okay, so this is how we are going to use multiplication of two determinants plus the factor theorem in a single problem. Okay, let's take the another concept, that is summation of determinant. So summation of determinant is a concept where, let's say this is the determinant which has a variable r. So here all this ai and bi, they are assumed to be constants, right? They are not the variables. The only variable here is r. Okay, so if variable is in one row, then the summation sign, if you take, will completely go into that particular row, right? Okay, so just understand that summation is being done row wise. So summation, what you can remember is summation is done row wise. This is the stuff that you people have to remember. But if there are variable in more than one row, so if more than one row has the variable, more than one row is there, one row has a variable, so what then you will do, right? So then you should not apply this formula because this will become very cumbersome. So what I'll say, resolve the determinant first of all, then resolve the determinant. This is the easiest step to do. Then I'll take examples of both the cases so that it is clear to you. Then resolve the determinant and then take summation, and then take summation. This is what you people have to do if this is the case, right? Otherwise you can take summation there also, but you will have to take row wise, then you will add somewhere. It will be a bit lengthy, which we do not want to do here. So let's take a question straight away. For example, this is what you need to calculate. This is dr and you want to find summation dr where r varies from 2 to n, right? So what will be summation dr now will directly go into the only variable you can see is in the row 1. So summation can be directly taken in row 1. So this is n minus 2 c r minus 2 where r varies from 2 to n. This is what is we need to find. Next element is again n minus 2 c r minus 1 and the next element is n minus 2 c r. R varies from 2 to n. Again here r varies from 2 to n and the remaining elements of the other rows remain unchanged, right? This is what is there with you guys. Now let's individually take all the elements. So the a11 element, what is the a11 element if we want to resolve? So this is summation of n minus 2 c r minus 2 where r varies from 2 to n. Now let's solve this. So this becomes n minus 2. The first value of r will be 2. So this becomes c0. Then you will have n minus 2 c1. Then you have n minus 2 c2 and this will go on till n minus 2 c n minus 2. This is what you will get. Can you notice this formula? We have done this in binomial theorem, right? This is nothing but the formula of, yes, you have mentioned it correctly. It is nothing but 2 raised to power n minus 2. That's it. Okay. Similarly, solving for the a12 element now. So a12 is given to be r varies from 2 to n. This is n minus 2 c r minus 1, right? So again it will start from n minus 2, but now it will start from c1, not from c0, but the remaining entire entity would be same, right? So how you can solve this? This is pretty much simple. Now you just need to calculate this particular value. So you subtract the first term from this particular value, which is n minus 2 c naught, which is nothing but 1. c0 is always 1, right? Irrespective of what is the index above. What is a13? a13 is nothing but that you will again start from 2, but now you will have n minus 2 c r. So if you put the first value of r, you will start from 2 now, right? So this particular series will start from the second term of this particular series over here. Okay, why I'm not writing it ahead, right? So CR. So in fact, you people can think of that, sir, you should have written CN also here, which is absurd. So there will be two more terms here, right? N minus 1 plus C n minus 2 to Cn, right? These two terms are not taken into count. Why? Because these are absurd terms. Because you cannot have these terms which are meaningless. You remember in NCR, R has to be less than or equal to N. That is the rule. So these are absurd. We will check them out. So you need to find the value of now these two up till this term. And this is already calculated. Now you want to calculate from this term to this term. So the answer would be nothing but 2 raised to power n minus 2 minus this term, that is minus 1, and minus this term. So NC1 is nothing but what? N, and n minus 2C1 will be this particular value. Okay, so this answer will be 2 raised to power n minus 2 minus n plus 1. So this is the answer to this particular. So now if you see, the summation sign is all gone. Now you are just left with the determinant. So what is the determinant that you people have now? 2 raised to power n minus 2, 2 raised to power n minus 2 minus 1, 2 raised to power n minus 2 minus n plus 1, and the remaining elements still remain the same. This is how you have to resolve summation sign. Okay, now the question is still not over. You were to solve this. So for solving, what you will do, there is already one 0 available. Can you see this? Now if I make another 0, my question will be done, right? So I can make this one also 0, right? So for this, what you will do, you will say C3 is nothing but C3 minus C2. If you apply this transformation, so this element will also become 0, and then you can easily solve this particular question. So if I do this for you, the remaining elements will not change. So let them be as it is they are. So this will be 1, this will be 1. What this particular quantity will be 0, this will be, yes, now that is the problem. So if you notice, this element will now also change, this will now become -1. So be very much beware of this particular tactic that we have to apply. So that means this transformation cannot be used. Think of some other transformation that will make this happen, that is 2 zeros. Yes, we have another option available. What is that option? Straight away do one thing, that you will take, now we can make this 0 rather than this, we'll make this 0. So that can be done simply by saying C2 goes to C2 minus what, yes, half C1, or you can also apply, you can make this also 0, that is not a problem. You can say C1 goes to C1 minus 2 times C2. So this 0 will remain intact and you will also get a 0, and then you expand. I'm leaving that part of the calculation for you guys to solve, because already this question has taken a lot of time in the video. So just do the calculation. My target was to make sure that you understand how summation is being done in this particular problem. Now let's take the other example of summation. If you can see this particular determinant over here, in this particular determinant, the value R is not in just one column. So R do not lie in only one column, in only one row or column, right? So it is in different rows and different columns, so we cannot directly apply the summation sign. So what we will prefer is, first we'll say resolve, right? What we'll do, we'll say resolve the determinant first. And even if it is difficult to form 2 zeros in the same row, so making 2 zeros in the same row is very adamant in terms of board. So board people will not give you marks if you do not make 2 zeros before expanding the determinant. But since we are targeting entrance, it doesn't matter whether you solve this determinant by making 2 zeros or by single zero or by non-zero. So do not waste your time in thinking about how the other zero will come in. You want to resolve, just simply resolve delta R if you feel that this is much more easy for me. So for example, if you just expand by row 1, right, so what you should get is something like this particular value, right? And if you feel this is much more comfortable for you, do not hesitate in going ahead with this particular step. So this is what, -4, this will be what, minus R plus 1 into 3 plus R, right? And if you resolve, what will be the value? Let's see. So if you try and resolve the complete value, this is the value that you will get, that is 8R plus 4. So that means the value of the determinant is nothing but 8R plus 4. Now you can use the summation, which is nothing but, you are very much accustomed to this. We did a lot of questions of this type in your summation series, right? So you can just simply solve this now, which is nothing but 8 summation R plus 4 times summation 1. So what is summation 1? Yes, it is nothing but how many times this will be repeating. This is from 1 to n, so this is nothing but 4n, sum of first n natural numbers, n into n plus 1 by 2. So this is nothing but 4n into, right, 4n, right, common आ गया, और अगला ये था बीच में plus. So this is nothing but into n plus 2. So this is the answer that you have to mark in the exam. Okay. Okay, the next important property that we have to do is differentiation of the determinant. And again, remember that differentiation of the determinant is done row wise, something very important. So it is being done row wise. So you will differentiate one row at a time. What do you mean by row wise? Differentiate one row at a time, right? You do not have to differentiate all the elements in one go. One row at a time has to be differentiated to find the answer. For example, if this complete function is containing x, every element is a function of x, so what you will do, you will first differentiate only the first row, then you keeping all the other elements constant, then you will differentiate the second row keeping the row 1 and row 3 elements same, then you will differentiate the third row keeping row 1 and row 2 same. This is how differentiation is done in terms of determinants. Let's apply this in a question straight away to understand the concept. So for example, this is the question and you want to find double dash a, right? You want to find the value of double dash a. So let's try and figure out first of all what is f dash x, that is the first derivative. As you can see here, the x is nothing but only in the first, in the second row. So you just need to differentiate the second row, forget about all the other elements. So this is what makes the question simpler for you guys. 6x and 4x cube, this is 1a square. So why I am not differentiating the other ones? Because let's say even if you differentiate this, 3 derivative is 0, 2 derivative is 0, this derivative will be 0, so all determinant will become 0, right? If you differentiate the row 3, this will be 0, 0, 0. You need not write this. You are wasting your time by writing this, right? Let's differentiate again because you want to find another derivative. So again 3, 2 and 1 will remain intact as it is, and the row 3 will also not change. The only elements will change as, yes, 12. This will be 6. This will be 12x square, right? This is what you will fetch. Okay. Oh, all right. So, okay, we missed something here. This is 6x square, right? So if you differentiate this particular here, so yes, so what you people will expect to get is 12x. Okay, my error. So now you wanted to find f double dash a. So now you just put the value of a here, and we can see that 12 is coming out common. So I can take 12 common. This will be 3, 2, 1. This will be 1 a square, and the third row is 1 a square. Two rows are same. That means this is nothing but 0. So the answer that you people were looking for is nothing but 0. This is how you find derivative of a determinant. Okay, let's take the next problem. It is given that LHS is a 2 cross 2 matrix and it is an infinite series on the right hand side. You need to find the values of a and b. So now there is another trick method of solving a and b, right? So if this is given to be equal to this, I assume this to be identity first of all. That means it is true for all x, right? That is what you mean by identity. If LHS is equal to RHS, always, that means whatever value of x you put is always true. So for a, how you can find a for a? So if in RHS leave this term, then you will get a. This can be achieved by putting x equal to 0. So in LHS and RHS, just put x equal to 0. RHS will only be a. So a is nothing but determinant when the value of x is 0, that is e raised to power 0. This is sine 0, this is cos 0, and this value is ln 1 plus 0. That's it. This is how you calculate a straight away. This value will be a implies a is 1, this is 0, this is 1, and this is again 0, right? Which is nothing but 0. So that means the value of a is 0. Now you need to find b, right? B is what? It is coefficient of b is coefficient of the x term, right? Now we have already done how to find. So understand how we have find a. A was constant, right? So for constant, how you find the value? By putting x equal to 0. Now b is coefficient of x, but if I differentiate, then this will be reduced to constant, and for constant we know how to solve, just by putting x equal to 0. So what I'll do, I'll differentiate first this question. So if I differentiate this, how you are going to differentiate? So let's say I differentiate. So differentiation will be done row wise. So the derivative of the first row is e raised to power x. Sin x derivative is cos x. I'll do not change the other elements, right? Plus now I'll differentiate elements of second row. This is minus sin x. This will remain intact, and this will be ln derivative is 1 upon 1 plus x. And if I differentiate the right hand side, a derivative is 0, bx will be b, and this will be 2cx, and this will go till infinity as given in the question, right? Now your target is to find b. What you will do? Yes, now you got hold of it. Put x equal to 0, that's it. So if you put x equal to 0, the value of the RHS will be nothing but b only, right? And this value will be what? Just put x equal to 0. So this will be 0, e raised to power 0. Cos 0 is 1, and this will be 0 again. This will be again, let's see what e raised to power 0 is 1, 0, 0, and this will be again 1, right? So what is the answer to this particular problem? This is minus 1, right? This value is 1 is equal to B, again the B values also comes out to be 0. So A and B in this particular case are both 0, and this is how you solve this particular problem. Okay, the next thing that we have to do is the integration of determinant, and it is completely similar to what you did for differentiation. So it is completely similar to the process of differentiation, right? So differentiation was done row wise, or I can say column wise also, right? So if I have not told you there, so it could be done either row wise or column wise. That means one row at a time or one column at a time. The same process is applied for integrations. For example, here you can see, so a to b integral delta x. If the variable is only in the first row, I'll just place the integral only in the first row. Had it been that these are also your variables, then plus exactly the second time we'll integrate row 2 elements. But I have not seen questions at the JEE Mains level where you will be asked to integrate quantities where more than one row has the variable, right? So let's see how the question actually is being brought up in this type of scenarios. So this is what you need to solve, that is 0 to 1 delta x. So x is only here, right? So 0 to 1 delta x, that means we want the function to be in terms of x. So where it is, so leave this component as it is, that is first two rows. Only the component of x will have this particular thing, right? And this will be nothing but beta square minus 2 again as it is. This is 4. Yes, now you will say 0 to 1 x square dx. Then you will go from gamma square minus 3. This will remain 3. This will become 0 to 1 x cube dx, right? And you just integrated integration. So in these kind of questions, the integration that will be asked of you is very simple. So this entire problem will be reduced to what? Just keep the other rows as it is. So the first thing that you should write is the other rows, right? This is what you will get, and this value will be x square by 2. This is 1 by 2. This is x cube by 3, that will be 1 by 3. This will be x4 by 4, so this will be 1 by 4, right? And you need to simplify this. So for simplifying, what you can do, what is the LCM here of these three terms? What is the LCM of the denominator? So LCM of denominator is 12, right? So what I'll do, I'll multiply and divide by 12 to make this equal. So this remains alpha square minus 1, beta square minus 2, gamma square minus 3, 6, 4, 3, and now I multiply the row 3 with 12. So this becomes 6, this becomes 4, this becomes 3. Now you can understand why this particular step was done. These two rows become same. The answer is 0 again. So the integral of this particular determinant will return you answer 0. Let's take the other problem for the integral part. It says that fx is given by this. Now you can see that the variable is in all the three rows. It is not in just one particular row. So how we are going to solve this now is, first of all, we'll resolve this, right? Resolve this to, first of all, to get the answer. So resolving, again, as I told you, if you are not able to make two zeros very effectively, don't worry, just simply do the normal calculation by expanding by row 1. So if I expand it by row 1, this will be what? 4 cos square x, this will be minus 1, plus 1 time this will be what? 2 cos 2x, oh sorry, not 2 cos 2x, it will be only 2 cos x, right? Okay, oh, and sorry, this will not be positive, this will be negative. So if I solve this, this will be what? Complete, it will become 4 cos cube x, this will be minus cos, and this will be minus 2 cos, so this will be minus 3 cos x, right? And now if you can see this, this is nothing but formula for cos 3x. So how simplified this question has become. So determinant was nothing but cos 3x. Now you just have to solve the integral cos 3x dx when it is from 0 to pi by 2. Okay, so the questions, believe me, the questions that are going to ask, they will be asking you will be very simple. They will not ask you very calculative problems. So do not just think of too much in terms of the calculative part. So easily answer is 1 by 3, very orally in fact. Okay, so the only stuff was to calculate this, which people actually hesitate when they see something of this sort. Okay. Now let's look into the system of simultaneous linear equations in terms of determinants. So if these are the three linear equation in terms of the variable x, y and z, so what you have to solve first of all is these four determinants in case of determinant, where d is nothing but determinant of the coefficient, that is a1 b1 c1, a2 b2 c2 and a3 b3 c3. d1 is nothing but replace the first column by d1, d2 and d3, where d1, d2, 3 are the right hand side of the three equations. Similarly, d2 replace column 2 with d1, d2, d3, and for d3 replace c1, c2, c3 with d1, d2 and d3. This is what is meant by d1, d2, d3. The answer to this problem, then the values of x, y and z are nothing but d1 by d, d2 by d, d3 by d. These are the values. So if we again draw the flow chart of when and what will be the answer, so there are four particular cases which generally arrive from the theory part. So for example, the first case, case 1, right, you will say that d is not equal to 0, right. Case 1 is d is not equal to 0. Also at the same time, d1, d2 and d3 all not 0, right. One of them might be 0, but all of them are not 0. Then I will say the equations are consistent. That means they will give you solution. That is the meaning of consistent. So they will be consistent, plus they will have non-zero, or in fact I should not say non-zero, but yes, they will have consistent, plus what you will say, they will have unique solution. They will have unique solution which is non-trivial. We know that what is the trivial solution? Trivial solution is the solution which is nothing but x, y and z are all 0, which is very obvious. Case 2, right. So the case 2 says when d is equal to 0, right. When d becomes 0, that means denominator is 0. That is where you will find some problem. Alright, so we'll talk about d equal to 0 here. Let's take when d is not equal to 0. So case 1 and case 2 have d not equal to 0, but this time around d1, d2 and d3 all are equal and all are 0. So here also I will say this is consistent, but I will say here the answer is only the trivial solution now, right. Trivial solution, right, that is nothing but x equal to y equal to z equal to 0. This is very obvious. You can see here, when will d1, d2, d3 will become 0? When d1, d2, d3. So in these, all these three will become 0 when you can say the d1, small d1, small d2, small d3 all become 0, and in this case they become homogeneous equation where d1, d2, d3 is 0, and their d also comes out to be 0, non-zero. That means only trivial solution is left for that particular case. Now let's talk about the case 3. So we have taken the cases where d was not equal to 0. So for d not equal to 0, one thing is for sure, that what is the answer? It is consistent, right? Now if we talk about the third case, that is when d becomes 0. So if d is equal to 0, what will happen? So let's take all of, again I will say all of d1, d2, d3 not equal to 0. Then the answer is straightforward. So what you will say in this particular case is inconsistent. And as the name suggests, inconsistent we know is nothing but, inconsistent means having no solution. So this particular case will have no solution when d is 0, but all of them are not 0. The case 4, which is the interesting case, which is in fact the least asked case in terms of IIT JEE Mains or the board, because it is calculative a bit. It says d is equal to 0 and all of your d1, d2, d3 are 0. So there are two possible cases here. It may have infinite solutions, and in fact in terms of CBSE boards you will definitely say that it have infinite solutions for 99.9% of the cases, but there is another case here which will say that it will have no solution. I'll take it this in a problem to understand for you people that how it is possible. It can also have no solution, right? Here when we say it has no solution, when you will have coincident lines, right? When you have coincident lines, I'll show you how it is being treated, right? When you have coincident line, how we are going to solve this, I'll take a special case of this. But this is the flow diagram that you people have to remember for system of linear equations in case of determinants. Okay. Now let's take a very basic case to understand this particular concept. It says there are three equations which are given to you as x plus y plus z is equal to 6 is the first one. Then you have x plus 2y plus 3z equal to 10, and there is another third which consists of now two parameters in the equation, that is lambda z is equal to mu. So I can straight away say that I have the value of d with me, that is 1 1 1 1 2 3, and this is 1 2 and lambda, right? What is the value of d1? d1 will be obtained by replacing the first column with this value, that is 6 10 mu. This is 1 2 2 and this is 1 3 lambda, right? Similarly, you can figure out d2 and d3 as well, right? So these are the values of d1 d2 d3. Now let's talk about what you want to find. Find the values of lambda and mu such that case 1. So case 1 is that you want to find a unique solution, right? So what is the condition for a unique solution? For a unique solution, first of all, d should not be equal to 0. This d, if you see, this is something very clear here, that column 1 is almost equal to, oh sorry, not the column 1, but I should reiterate, it is row 2 and row 3, right? Row 2 and row 3 here are actually almost same. If lambda is not equal to 3, then I can assure that this is not equal to 3. So when lambda is not equal to 3, d is not equal to 0. Okay, so this is the answer we were looking for, unique solution. So for unique solution, d should not be 0, as we have done this in the previous cases also. You can see there, here it will be a unique solution when d is not equal to 0. Either it will be non-trivial or it will be trivial, but it will be a unique solution. Let's talk about case 2. Now case 2 says that find the values of lambda and mu for which this will have infinite solution. So for infinite solution, what you will do is d should be equal to 0 and d1 d2 d3 should be equal to 0. All four should be 0. Now d is equal to 0, we know that value is lambda is equal to 3. This is we know. Now when this will become again d1 d2 d3 equal to 0, all three 0, when will this happen? Now let's see d1. So d1 is here. So now this is already 3. This is what you have already calculated. This value is already 3. So if this value is already 3, d1 is already 0. If this is 3, this is 3, then this value is also 0. So now what is left to calculate? Yes, this here. Now this is also 0. If you have the value of mu here as 10, can you see this? If the value of mu here comes out to be 10, then the row 2 and row 3 again will be same and d3 will be 0. So that means for infinite solutions, you want the value of mu here as 10. So the answer to this will be that lambda should be equal to 3 and mu should be equal to 10. This is the case. Now the case 3 asks you, case 3. So the case 3 asks you that no solution, right? No solution. So for no solution, what will be the criteria? Just go back and see. You have no solution when what is happening? D equal to 0, but all of the d1, d2, d3 are not equal to 0. Then there is a short answer that you will have no solution. So d equal to 0, we want d should be equal to 0. That implies lambda should take value 3, and we want all of them, all d1, d2, d3 are not equal to 0. So as soon as lambda becomes equal to 3, we know that d1 equal to d2 will be 0. Now the only possibility left is that d3 should not be 0. So when will d3 be not 0? Yes, obviously when mu is not equal to 0. We want d3 should not be equal to 0. This is possible when mu is not equal to 10. So the answer to the case 3 is that lambda will be 3, and when mu is not equal to 10, then you will have no solution, inconsistent solutions basically. Okay, so this is a very basic problem that you should revise to understand all the three cases which are the most famous three cases. Okay, now let's take the next problem. It says again you have three equations. So what is the value of d here? D is 1 1 1, this is 2 2 2, this is 3 3 and 3. Now this is obviously is 0 because all the three rows are in fact same, right? What is the value of d1? D1 is by replacing the first column. This is 1 3 4, this will be 1 2 3, this will be 1 2 3, again this becomes 0, and similarly if you solve you will get d2 also 0 and d3 also equal to 0. So this is a case where all the four d1 d2 and d3 are all equal to 0. So now I told you that this could have actually two cases. Either it could have infinite solutions, right, or this could have no solution also. So now target in this particular problem is to teach you why this has no solution here. Okay, so how do you solve these kind of questions when all of them are is equal to 0? Generally what you do, you put z is equal to t and you want to find solution in terms of t. So z is a parameter in terms of t, then you will find the value in terms of t of y and x. Okay, so if I do this, and now I'll treat this as a constant now for the equation. So this becomes x plus y plus t is equal to 1, and the second equation will be 2x plus 2y plus 2t equal to 3. Let's solve these two equations because these are equation in two variables now. So this will become x plus y is equal to 1 minus t. This will be 2x plus 2y is equal to 3 minus 2t. Right? Can you see this? So can you notice these two are nothing but parallel lines, or in fact if I reduce this, this becomes x plus y is equal to 3 minus 2t by 2. You can see that this and this RHS should now be same. So if you try and solve this particular case, that is 2t by 2, what it leads to is 2 minus 2t is equal to 3 minus 2t, and if you check this, t cancels out and you get 2 equal to 3, which is never possible. So in fact this gives you there is no value. So what does this mean? That there is no value of t, no value of t for which both of these equations will be satisfied, right? If there is no value that you can find, that means, that is the reason I was saying you will have now no solution for this particular category, because even if you put z equal to t, you will not be able to find any value where x and y will be solved simultaneously. So despite getting d equal to d1 equal to d2 equal to d3 equal to 0, you could have a case which will have no solution. Clear? Okay, now just imagine if I change these conditions of these three equations, I just change the RHS, that is 2, 4 and 7. So the values that will be here will be x plus y plus t is equal to 2. Then you will have 2x plus 2y plus 2t equal to 4 here, right? This is what you will achieve here. And if you now notice, these two equations are actually the same, right? So that means this will have infinite solutions now. This will have infinite solutions. Why? Because even if you put this value, you will always get the same result. So what will happen here is x plus y is equal to 2 minus t. So now y can be said that it could take, let's say, variable t2. So then t1 x can be written as in terms of 2 minus t1 minus t2. I assume this now is t1. So now the parameters are in terms of x, y and z, and if as you change t1 and t2, different values of x will be achieved. This is an answer for infinite solution, whereas here in this particular case we were not getting even a single value of t which will satisfy both the equations. That is why it was leading to no solution. Okay. Okay, so by this we come to the end of the topic, where we have covered all the topics which are relevant towards your entrance examinations. I'll be sending the worksheet. Just solve it and practice it so that you can fetch that 4 marks that comes from this particular chapter. Again, it's an easy chapter which you can score easily. Do not fuzz around doing tough problems over this chapter. And the CBSE topic is completely different. So for CBSE, what I'll recommend that you solve the RD Sharma stuff. Right, for CBSE, you need to get through your NCRT plus your RD Sharma, right? That is the requirement. But yes, for the entrance, I'll now prescribe for entrance examination. So you need to solve plus the worksheet also for this, which I'll be sending across. Okay. For NCRT, as usual, you can just go on the videos which are there already on our YouTube channel. Okay. So I hope you are learning is completely getting productive by watching these videos. So I'll come up with the new chapter tomorrow. Till then, keep learning, keep studying. Good night.